All right, so welcome back. Today in this video, we are going to be looking at some important formulas for the mathematics section of your Civil FE exam. We're going to be focusing on statistics. So statistics has a lot of variables and symbols and things that seem to honestly try to confuse you. And so we're going to break down what's going to be on this test and what we need to pay close attention to. So we're going to start by using our reference handbook because that's where our important formulas are going to be at. To get here, if you're in, you want to download your reference handbook and just use your bookmarks and go to your appendix section with FE exam specifications. And you just want to click on civil. All right. So we are going to be looking specifically at this statistics section where we're going to be looking at distributions, mean, mode, standard deviation, confidence intervals, and regression lines and curve fittings. So let's dive right into this. All right. So I want to start with standard deviation. So the first thing we need to know is that this is probably going to be in the engineering probability and statistics section. So we need to just click to that bookmark so that when we do a search, it kind of helps us put us in the right area. Okay, so you can see this says mean, median, mode values. But I guess we will start with standard deviation, right? So what is standard deviation? Well, standard deviation is just really trying to show you what the difference between data, how much data varies. So, for example, if you have 5 different quarterbacks, right? One throws for 10 touchdowns, one throws for 20 touchdowns, and then one throws for 100 touchdowns, right? The difference in data is going to vary. So your standard deviation is going to be, it deviates. It's much different versus you have quarterbacks that all throw for about the same amount of touchdowns. So let's say one throws for 20 touchdowns, one throws for 21, then one throws for 22 touchdowns. All that data is very similar. So your standard deviation is going to be, a bit smaller. So that's all we're doing here. So this formula, this population formula is very, very important. And it's typically what you use to calculate your standard deviation. So what is this saying? Well, this symbol here is standard deviation is equal to the square root of 1 over n. What is n? N is the number of samples, or the number of quarterbacks in this case, right? And so if it was 6 quarterbacks, this would be 1 over 6. Okay. And then you're going to multiply that by the sum of you're going to have your sample xi. So, xi represents the value of the observation. So like on the example, if the average, let's say, for example, the average touchdowns that are thrown is going to be 10 touchdowns. So that is going to be my mu here. And then xi is each individual quarterback's touchdown amount. So maybe one quarterback threw for 5 touchdowns. So you're going to, for this particular example, you're going to say 5 minus your 10, and then you're going to square that, right? And then you're going to add up the next quarterback and what their difference from the mean was. So that is how you get the standard deviation. Is basically you're comparing an individual versus the overall mean, and it's telling you the difference and how much your data varies, right? So that is standard deviation. And we kind of touched on a few more things, right? So what is the mean? Well, the mean is just the average, right? So you take the sum of, or you add up all of, I guess here's a kind of a good example. You take up everything that you're dealing with. So x1 plus x2 plus x3. We may say 5 touchdowns plus 10 touchdowns plus 20 touchdowns. We take it all over the amount of quarterbacks that we have, and that gives us the mean or the average, right? What is mode? Mode is what appears, and some of this, a bunch of this is just stuff. So mode is what repeats itself, so the most. So in your data set, you're going to have a bunch of data given to you. So you may, I'm going to just keep using this touchdown example because I love sports. So in football, you may have a lot of quarterbacks may throw for 5 touchdowns. So that may be the mode, or how it's the number that repeats itself the most. Hopefully this is a refresher for you, and it kind of makes sense. All right. Let's look at variance. So variance is just going to be standard deviation squared. So this stuff here, or on the right side of this equation, is the same thing as this. So if you were to take this square root on this side and put it on the other side and square this would be variance now. So it's the same. This is the same thing. It's just variance is just standard deviation squared. Okay. And they may ask you for that. What else? All right, let's look at distributions. Distributions are going to be a pretty important thing on this for the few problems that you get on it. Now, there are a few different types of distribution. And before we look at distribution, what is distribution? Well, distribution is just you trying to determine this probability, right? And we'll wanted to pull something up for you that kind of shows this. So this will really put things into perspective. So you have this bell shaped here. This is something that's normally distributed. And so these individual sections share a percentage of the data. So you may have, if you're going from -1 to 1, you will have 68%. You will know 68% of the data. All right, or you will have 68% of the data. If your standard deviation is, or if your data is from -2 to 2, now you have 95% of the data. And then if it goes from -3 to 3, right, then now you have 99.7%. So it just keeps increasing the further out you go as far as standard deviation is concerned. All right. So one standard deviation would be from -3 to -2. So you can see how the further out the standard deviation is, the more range of data that you cover. All right. If your data is, wide ranging, but you only are getting a small amount of it, and that standard deviation doesn't vary too much, you may only get 68% of the data. So this is how normal distribution kind of is shown. And I want to take a look at, okay, there's also another distribution called T distribution. So let's go to normal distribution. So to look at some of the formulas that are involved with normal distribution, we want to do a search for it. So I'm just going to do normal distribution. Okay. It's also known as the Gaussian distribution. I think I wonder if I said that right. I'm hoping I did. But this is the section that you kind of want to be in. But basically, this is just telling you that there is a function, which this I wouldn't say that this is the most important thing, but there is data that is distributed by a function, and that function is f of x. And so other things that are involved with this is you should have your population mean, which is there. You have some standard deviation involved, and x, which is the value when you're comparing it to is this should be the sample. Okay, so what's important here, really this formula is important. You want to, so it should be noted that for any normal distribution with mean mu and standard deviation sigma, then, or that symbol, the table for the unit normal distribution can be utilized or can be used by utilizing the following transformation. So we have z is equal to x minus mu over sigma. So basically, they're going to give you some information, and you're going to want to find pretty much what is the probability. That's basically all you're trying to find. That's that z value. So you're going to have whatever x is, you're going to have a population mean, and then you're going to have a standard deviation, and they're going to say what's the probability. Okay. So when you're dealing with normal distribution, it's normally your n value is going to be the number of samples. When I say n value, I'm just saying the number of samples is a large sample size. So that's when you're dealing with normal distribution. When you're dealing with t distribution, it's a smaller sample size, typically under like 30. And so it's very similar as far as what it is that's being distributed. It's just a smaller sample size. And the important formula here is going to be that it's going to be this. So that sample minus your mean over S, which is standard deviation, divided by the square root of n, which is going to be the number of samples. So that will give you your probability. All right. Other things. Confidence intervals. And I think we may pass linear regression, so I'll just go over linear regression real quick. Linear regression. So with linear regression, you're going to be dealing with basically there's going to be a bunch of data that you're given. And so that data sometimes can, if you're plotting it on, let's say, a X and Y coordinate system, that data can be similar to some sort of line. So they may say the faster a person can run. So they may say how fast can a person run, and then equals how many races, and then you'll see how many races they've won. So as the faster you are, the more races you win. So that the data may support that, and so it may form this some sort of a line. And I'll just do a linear regression image, just so you kind of have an idea of what I'm trying to explain. All right, so you may have all these points plotted, and so as your linear regression is basically you drawing a line that best fits that data. Okay, so here you can also, by creating that line is going to equal y is equal to a plus bx. Well, this is just the equation of a regular line. Y equals mx plus b, if you know that, but it's just saying it in a different way. So what is a? A is just a y-intercept. And then what is b? B is going to be your slope. Okay, so y is equal to mx plus b. It's just different symbols. And if they're giving you SXY and SXX, they will literally write that out. It's just the sum of squares of the X, and then the sum of squares of the Y, or the sum of XY products. So they will give you that information, or they will give you this equation, and then they'll say, hey, from what we've given you, solve it. Okay. I think there was maybe a few more items that I wanted to go through on t-distribution, or it might, I think it's, let me go to, should be some tables. Okay, so I failed to mention this, but when you have normal distribution, so this is something I want to add. When you're doing normal distribution, you're going to have some sort of probability that you may, or range that you may be looking at. So if you want to see a certain percentage of the data, kind of like with the normal distribution stuff we were looking at, where you're having these standard deviations, this is highlighting that. So depending on what X is, it's going to tell you how much of the data you're able to get. So you may just want to see, the problem may ask, from a certain range, and you may want that information, or you may want, so it may say how many quarterbacks can throw 10 touchdowns or greater. And so that captures this. It would be 10 and whatever else, right? For this one, how many quarterbacks are able to, how many quarterbacks throw less than 5 touchdowns? And so whatever this threshold is, 5 touchdowns and back, that covers that data. They may say what quarterbacks throw either below 5 touchdowns or above 20 touchdowns a year, and so that covers this. And then between between 5 and 10 touchdowns, this covers that. So that's how you want to be able to read these charts as you're going through. And I do practice problems as well, so you can check those out in a separate video. All right. What else? Okay, confidence intervals. So confidence intervals are, you're going to be looking at, how confident are you that, for example, how confident are you that the quarterbacks for this season are going to throw 10 touchdowns? Are you 95% confident? Are you 100% confident? And I don't even think you can do 100%. I think you can say like 85. So I'll look at basically this formula gets you to say how confident you are. So this is basically saying that X bar, which is the sample mean, minus Z or alpha or whatever that is, divided by 2. Okay, so that is going to be something that you're going to have to grab. And so you grab it from this confidence interval table. So if, depending on how confident you're trying to get, that's the value you're going to pull. So if you want to be 80% confident that quarterbacks are going to throw whatever amount, then you're going to use the 1.28 in that case. If you want it to be 99% confident, then you're going to use 2.55 or 2.57. So that is the number that you plug in for this little value here, right? All right, so then you have your standard deviation all over your the square root of n. So this is another section that you need to kind of be familiar with. You can have a lower bound and an upper bound. It's basically all that saying for a particular mean, right? So whatever the real mean is, it's between your upper, it's between this interval, this confidence interval. And so you can take whatever you're saying, whether it's lower than the mean or it's greater than the mean, you can say, okay, how confident are you that it will be that, right? You can also do this with t distribution as well. So similar idea. It's just different values there. So typically you're going to be, if you're not able to, so let's say you want to find that typically you're not going to deal with this one too much. You're going to deal with this top one. So I think those are the main things. So let's just go back to make sure. So we have covered distributions, t distribution, normal distribution. Normal is for large. T distribution is for smaller samples, normally under 30. Mean, went through that. Mode, went through that. Standard deviation, confidence intervals, regression lines, curve, and fitting. So pretty good amount of equations that we can use, and a pretty good amount of knowledge that you need to know going into this thing. So they're not going to ask a ton of questions on this stuff, but I think like there's going to be 8 to 12. So if you divide that up, it's maybe, 2 to 3 questions a piece. So you may get 2 to 3 questions on statistics, but still we want to make sure we're dominating everything. So I think this will help. So hopefully you enjoyed this video. If you have questions, leave it. If you have comments, feel free to leave it. And I will see you in the next video. Peace.